Salite, this should help you relate magnification, image size, and actual size. So our question is, what is the magnification of the snout beetle? So we have a picture of a snout beetle here. This is not how big the snout beetle is in real life. So the question is, how much bigger is this picture than the snout beetle is in real life? What's the magnification? So let's approach this step by step. We are looking for the magnification, which in our relationship is m. The relationship that we have, it's the same one that we're going to use for any problems of this type. So m equals I over a. So I is what we measure with a ruler on the image or on the actual paper. So measured with a ruler on the image, I'm going to circle that I. And then what do we mean by A? A means actual size. So the actual size in real life is A. Okay, so we know what we're looking for. We know what the relationship is. We have 3 variables here. We must be provided with 2 of them. That's how algebra works. So what are our givens? We must have at least 2. Well, we know that the scale bar is telling us that in real life, the actual distance from this part to this part of the snout beetle is 100 microns. So we have given A equals 100 microns. And we might think that that's all we have, but it's not, because we get I by taking a ruler, taking a real ruler and putting it down on the image. So I'm going to call that 3.2 centimeters. It's close enough anyway. So measured with the ruler, 3.2 centimeters. Okay, so if we are just subbing in, let me do a line so I know where we started our calculations. If we're just subbing in, we would think, okay, we've got it made. M equals I over A equals 3.2 centimeters over 100 micrometers. And that would be okay, but I hope some alarm bells are going off for you, because of course these need to be in the same unit. You can't have different units in the numerator and the denominator. So we need to do some conversions. I decided to give myself a fresh piece of paper instead. Okay, so we can't move any further until we do some unit conversions. So I'll go over here. 3.2 centimeters. We are trying to get to micrometers. So we need our centimeters to cancel. And we have to go through our base unit, which is meters. So we know that 1 centimeter is 1/100th of a meter. We know that 1 micrometer is 1/1,000,000th of a meter. So simplifying this, we have 3.2 times 10 to the negative 2 over 10 to the negative 6. By our rules of exponents, that's 3.2 times 10 to the positive 4. So negative 2 minus a negative 6, positive 4. So that's 32,000 micrometers. If you're a little confused about the units, going back here, we were able to cancel centimeters, cancel meters, and we got our answer in micrometers. If this part is confusing to you, you can review your rules of exponents from algebra. You can also look at my unit conversion video. Okay, another way that we could do this, if you're feeling stressed out by these negative exponents, we could do this. 3.2 centimeters. We're trying to get to micrometers. We need centimeters. Oh my gosh. 3.2 centimeters. We're trying to get to micrometers. We need centimeters to cancel, and we have to go through our base unit of meters. Okay, so I don't want negative exponents, but I'm going to represent the information in a different way. It's the same information in a different way. So 1 meter is 100 centimeters, also known as 10 to the second centimeters. 1 meter is 1,000,000 micrometers, also known as 10 to the 6th. So now we have 3.2 times 10 to the 6th over 10 to the 2nd. Same rules of exponents. 6 minus 2 is 4. 3.2 times 10 to the 4th. Look at that. We get our same answer, 32,000 micrometers. And in this way, we were able to avoid the negative exponents, but you have to keep track in your head what's going on here. So this is telling you that a centimeter is 100th of a meter. This is telling you that there's 100 centimeters in 1 meter. Logically, that's the same thing. So you can do it either way, just don't get confused. Okay, one other thing that we could do if we're really allergic to exponents is we can do this. 3.2 centimeters. So I needed centimeters to cancel, and I needed my base unit of meters. So, okay, I don't want to use powers of 10 at all. That stresses me out for some reason. So 1 meter is 100 centimeters. 1 meter is 1,000,000 micrometers. So it looks like a lot of zeros to me. I'm going to cancel them. And now I end up with 3.2 times 10,000 microns, also known as 32,000 microns. So these are mathematically and logically the same thing, but pick the one that's best for you and stick to it. Are we done? Wait, I forgot what we were doing all this for. It's because we had to figure out the magnification of this snout beetle. So going back here, we figured out that 3.2 centimeters is the same as 32,000 micrometers. So magnification is equal to 32,000 micrometers over 100 micrometers. We could put that in our calculators, but I don't think we need to. Our units cancel, which should make sense to us because magnification is unitless. So we get a magnification of 320. And what that means is that this beetle, the picture of the beetle is 320 times as big as the actual beetle. So the magnification is 320. This picture is 320 times as big as the actual beetle. And sometimes we represent magnification with just an X, so 320 times.